theory. VSEPR means valence shell electron pair repulsion theory. Okay, and there we have done the model A, B to E. So I told you, moment you get A, B to E, then you think that our original model was that you have learned, it was AB3. And how was the structure of AB3? Structure of AB3 was trigonal planar. This is what is electron pair, or which you call it, in your book is electron pair, in many books they write L, or this lone pair. So what will be the AB2? What is this? See, AB3 is A, B, B, B. So when one of the B is missing and with an electron pair, so I'll try to put E here. A, B, B. Okay. Now I'll write it in this way. Then it will become a little easy for you to understand. I'll write it in this way. A, B, B, and B. Then A, B to E is, I remove one B. So this A, B, B, and this is E. So this is not visible. So how it will look like? It will look like this is visible. Not visible to our naked eye, but in X-ray. So how do you call this structure? It's called bent or V-shaped. Example, we have done sulfur dioxide. So how do you find this structure? So valence shell electrons of sulfur is 6. Number of bond pairs, 2 oxygen, so I'll 2. Number of lone pairs. Okay, how to calculate? I told you this is the main mistake of VSEPR. While they write, they do not find a distinction between single bond and double bond. But in calculation of lone pair, you have to find. See here, oxygen has 6 electrons, so it takes 2 electrons to form oxygen 8. Okay, so in this case, if the sulfur is having 6 electrons, see here right now. If the sulfur is having 6 electrons, 2 electrons is taken by 1 oxygen. Other 2 electrons are taken by another oxygen. Okay, so though we have written bond pair is 2, but how many electrons got engaged in forming bond? Here it is 2, and here it is 2. So 2 plus 2 is 4. Then number of lone pairs will be equal to what? Is equal to 6 is the valence shell electron. 1, 2, 2, 4, 6. How many electrons has taken part in bonding? 2 plus 2, 4. So it is 2. Okay. Now what is there? Pair means what? 2 makes a pair. So what should I write it here now? It is equal to 1 pair. Is it not? So what I'm going to write here? I'll write here I'll write here 1. Okay. So what is our model now? What is the model? Model is A, bond pair is 2, B 2. Lone pair is 1. E. So what will be the structure now? Structure is sulfur, and this is the one. So it is bent or V that we have done in the last class. I've just revised to so that again you can remember. So I think you again write it. Please write it again. Now we will go for A, B, C, E. Then is what? It is equivalent to, I told you, no, immediately you think E is B. This is equivalent to AB4. Okay. Now, what is the structure of AB4? Structure of AB4 is that we know. It is tetrahedral. Okay. So see here A, this is the one. This is our tetrahedral structure. But when you go for AB, structure of AB3E, so one of them will not be visible. So say this is not visible. So right now here. See, this is not visible to us. This is not visible. So what has happened? See, the lower structure remains same. So as it is not visible, what has happened? The height of the tetrahedron is decreased or not? Height of the tetrahedron is decreased. So we can call it distorted tetrahedron. But for distorted tetrahedron, we have a typical structure in geometry. We call it pyramid. So this is pyramidal. This is pyramidal. Draw.
রিপোর্টটা কি 8টার সময় গিয়ে আনতে হবে না পরে?
We'll do example. Ammonia. Okay. Now, what we'll write now here? Then the electron of nitrogen is 5. We know hydrogen always links with other with single bond. That is, each hydrogen takes 1 electron from nitrogen. So what should I write now here? So bond pair is what? How many bonds are there? 3. For each bond, hydrogen has given 1 and nitrogen has given 1. So how many electrons nitrogen has given? 3. What is the total number of electrons? 5. Then how many electrons did not take part in bonding? 2. So 2 makes a pair. So here, what is the model? A, B, C, E. So what is the structure now? So this is not visible. So we'll write here this. Then what is the structure? Filament.
ফুলকপি দিয়ে ঝোল করে দেবো একটা। ফুলকপিটা তো ফুটতে চাই।
So done.
Will be like this. In your exam, they may not give you ammonia. They may give you NCl3. Same. Valence of chlorine is 1 out of 5 electrons of nitrogen. 3 chlorine will take 3 electrons from nitrogen. So 5 minus 3 is 2. 2 is equal to 1 pair. So it will be all pyramidal. Same is the case with what are the other elements present in nitrogen group? Nitrogen, phosphorus, arsenic, antimony, all of them are going to form pyramidal structure. Now, I'll go for AB2, E2. So substitute E by B. So what will be the structure? Tetrahedral. Okay. In tetrahedral, there are 2 lone pairs. The lone pairs will not be visible. Okay. So I'll write now here. Don't AB2, E2, equivalent. In exam, we don't like this. This is for your understanding. Equivalent to AB4. So what is the structure for AB4? AB4 structure is A, B, 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 B. Let me substitute this B by lone pair. What will be the structure now? It will be A, the lone pair, B, this is the lone pair, B. See, these two will not be visible. Then how it will look like? It will look like this only. They are there, but they are not visible. So how it will look like now? It will be band or V shape. Example is H2O. So what will write here now? Valence shell electrons of oxygen. 6. How many bonds are there? 2. So number of bond pairs equal to what? 2. So 6 is the number of electrons. How many electrons taken part in bonding? 2 only. Okay. So this is oxygen. This is, you see, this has taken part in bonding. This is taken part in. These 4 of them did not take part in bonding. So in 4, how many pairs will be there? 2. We write now here number of lone pairs is equal to 2. So what is the model? Model is AB to E2. But AB to E2 is equivalent to what? AB4. So what will be the structure? The structure is O, H, H. And these are the invisible lone pair. Okay, so this structure is band or V shaped. Okay, suppose they ask you to write H2S. H2S. So see, oxygen, sulfur, selenium, tellurium, and polonium. They are in the same group. So all of them have the same number of valence shell. So what will be this? Sorry, sulfur. So it is 6. All right. So what will be the shape of H2S? This. Write down. For H2S. AB4E. What is the equivalent structure? Immediately remove E and put B. Equivalent to what? AB5. All right. Now structure. Now we know what the structure. Structure is trigonal bipyramidal. Okay. So I'll write it like this. A C. This is B. This is our trigonal bipyramidal structure. So I'll remove one of them by a lone pair. Okay. See here. Now AB4E. So what I'm going to type? B, 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 and this is this one. This is not visible to us. How does it look like? I know it is a bit difficult for you to visualize. So I'll allow this. This is the vertical structure. I'll make it horizontal. See that. Have you seen this structure in park? In children's park, have you seen this type of structures?
No, sir.
Yes, you have seen it. Have you seen this type of structure in park?
Yes, sir.
What is
Yes,
that
sir.
called?
Sir.
Huh?
Seesaw.
Yes. So this structure is called seesaw structure. Let's do the example. SCl4. See, number of valence shell electrons of sulfur 6. So this is sulfur. Okay. 1, 2, 3, 4, 5, 6. Okay, I write it like this. 1, 2, 3, 4. This is bonded with one chlorine, another, third, and fourth. So how many bond pairs you have? Count the number of atoms. 4. And because valence of chlorine is 1 only, so number of bond pairs equal to 4. All right. Number of lone pair. Number of lone pairs that we can find. Totally 6 electrons. 4 has taken part in bonding. then how many electrons left out? It is 2 electrons equal to what? 1 lone pair. So number of lone pairs equal to 1. What is the model? Model is AB4E. All right. So draw the structure. I will not draw for you. Write it like this. Structure will be what? Then draw it.
Excuse me, sir.
Yes.
Number of bond pairs, it should be 4 or 2.
Number of bond pairs is 4. How many chlorines are there? 4, na? So number of bond pairs is 4.
Mm,
See. Look here. You know though. See. See, this is one pair. This is another pair. Another pair. And this is the fourth. Sulfur is how many electrons? 6. So 1, 2, 3, 4. And this is the lone pair. It did not take part in bonding. How many bond pairs you have? 1, 2, 3, 4. So 4. Number of lone pair? 1. Understood?
Yes, sir.
Huh?
Thank you, sir.
So if you have doubt, you can, in one side you can write it. So you can write here. Bond pair 4. Lone pair 1. So this is what is the model here. Here the model is, I forgot to write the model. AB4E. I think I have drawn it, na? AB4E. This is the model, right on the top of it. Now we'll remove one more by lone pair. Okay, so I'll write down here ABC E2. Immediately you think, what is the equivalent structure? Remove E, put B. Equivalent structure is what? Equivalent structure is AB5. AB5. Achha. No, I want to discuss a little bit more because these structures are being based on lone pair, bond pair, lone pair repulsion, lone pair, bond pair repulsion, and lone pair, bond pair repulsion. So let me again please go back. I'm very sorry. Simply you should not by heart. You should use logic. Say AB4E. Why did I decide the structure should be like this? Why should be like this? See, our original structure is what? A, B, 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 and B. Okay. This was the ordinate structure. Then why did I decide? Why I did not remove this B from here? Okay. So let me write two structures. See, I told you this is on the plane. These three B are on the plane, and this is perpendicular like this. All right. So why did I remove this one electron from the plane? Why not from the axis? See. So I draw the other structure also. This you try to understand. I'll write like this. B. I could have taken this. See, when I remove this one, I call it seesaw. And when I remove this one, see how does it look like? Does it look like a pyramid? Huh? Then it should be pyramidal. Then why did you take this? Why not this? Huh? We could have taken this one also. See, look here. Let us try to find out their repulsion. See here, what is the bond angle here? 120 degree. What is the bond angle here? See, it is like this. All right. So this is one B, this is one B, this is another B, this is another B. Okay. You have a B here and you have a B here. So I have put the lone pair here. Okay. So what is the angle here? It is 90 degree. What is the angle here? 90 degree. The repulsion between this and this is the lone pair bond pair repulsion. So how many lone pair bond pair repulsion you have? You have two lone pair bond pair repulsion. All right. And how many bond pair repulsion you have? See, this is, I'll write on here. This is E, I'll write here, EB. Okay, here you have EB and here you have EB. Now, how many bond pair repulsion is there? Look here, look. This is the bond pair, this is the bond pair. Here you have lone pair. So, this is 90 degree and this for this one is also 90 degrees. So, you have one lone pair bond pair repulsion and you have one lone pair bond pair repulsion. Lone pair bond pair, strongest repulsion is lone pair repulsion, followed by lone pair bond pair repulsion. Now, see here, you have a bond pair here. Okay. So this is the bond pair, this is the bond pair. So you have one bond pair repulsion, you have another. So first, second, then third and fourth. Fourth bond pair repulsion. Let us come here. Look. In this case, see, this is the lone pair. This is the bond pair, this is the bond pair, and this is the bond pair. All are 90 degree. So you have one lone pair repulsion, second and third. And how many bond pair repulsion you are having from the top? Okay. So it is here B is there, here also B is there. So 1, 2, and 3. In that case, you have 3 lone pair bond pair repulsion, and here 3 bond pair repulsion. Okay, now repulsions. Otherwise, you will be by hearting. You should not by heart. What is the repulsions? You find here lone pair repulsion is strongest. So then after then comes lone pair bond pair repulsions. Then after that you have bond pair repulsions. So where you find repulsion is more. This repulsion is more. All right. So what should do right now here? This is the repulsion. So because of that, we take this structure, we don't take this structure. So what should I write now here? I'll write now here. Justification of structure. Justify. Hence, everything there should be some justification. It's not imagination. So we'll write now here in pyramid. You should write below this one. Oh, yeah, we'll write now. Therefore, in pyramidal structure, repulsion is more. Therefore, AB4E has C so structure. We'll do example. Example we have done, no? We have not done. I have already shown you. Okay, I'll write down all these things. Valence shell electrons of sulfur. You'll write it. Number of bond pairs. Number of lone pairs. Model and structure. Model, do you know it will be what? AB4E. Do. A, B3E2. Okay, what is the equivalent structure? Same only, AB5. Equivalent structure is no structure. Equivalent model is what? AB5. Immediately think. So what is the structure of AB5? Structure is trigonal by pyramidal. Structure is this. This is the structure. Now I'll go for. So I'm going to replace any of the B. Let us see. See, I have to remove now two structures. Two B. See, what are the types of B I have here? These are all equatorial B. This is in the plane. It is like this. 1, 2, 3. Okay. And this is the axis. You cannot say like, see. So B. One B is here, one B is here. So let me remove this 2B from equator. So how it will look like? B. What do you have here now? These are the lone pairs. Then next what I'll do? I remove both the axial B. Okay. This is in the plane. Okay. Then I remove this axial B. So how will it look like? Simply triangle. These are not there. You can't see them. It looks like a triangle. Then what I can remove? I can remove one from axis and one from equator. So I'll write like this. B. This is from the axis. This is B. So I have three structures. 1, 2. So let us count. Let us count the lone pair bond pair repulsion. See, here the angle is 120 degrees. All right. All right. Now, what is the angle here? This and this is 90 degrees. This is 90 degrees. So let us see here. How many lone pair bond pair repulsion you have? Here, see, lone pair repulsion is maximum when it is 90 degrees, but it is 120 degrees. So I write now here A. Minimum lone pair repulsion because it is 120. Then what you have here now? See. Lone pair bond pair repulsion. Lone pair bond pair repulsion. All right, now see. Here you have a lone pair, here you have a lone pair. So it is 90 degree to this B, it is 90 degree to this B. See here. So how many you have? 1, 2, 3, 4. 4. All right. Now let's come here. See here. This is 90 degree to all of them. 90, 90, 90. All right. So what we have now here? Lone pair, bond pair, repulsion. Sorry, it's not 3. This is 1, this is 2, this is 3. Then from below also you'll have, na? See. 1, 2, 3. Then see, this lone pair is also 90 degree to this. So 4, 5, 6. 6. Okay, let us come here. see here. This is 90 degree. In C, what you will find? Here you will find a third structure, maximum lone pair repulsion. Okay. See, this is the lone pair. This is the lone pair. So you have maximum mention repulsion is there. Then see, this one is 90 degree to this. So lone pair bond repulsion. Okay. Then this is 90 degree to this. So what will have? One lone pair bond repulsion. Then second, and this is third. Okay. So here you will have LP, GP. Here you have LP, BP. Here you have. So yes, this is A, B. What will have now here? Lone pair, bone pair, repulsion. How many you will have here? See, 1, 2, 3. So this one I can rule out immediately. I can rule out because of this. So this structure is not possible. If I compare with this and this, which is having more repulsion, this and this I cancel. So this is the structure that you have adopted. So this is the structure you adopted. Everything becomes stable when there is let me wrap. See, my question is that I am not writing so many structures to confuse you. I want to tell you the structures are totally based on argument and logic. And BSAPR deals with only with the repulsion theory. Okay, now see here. So what will be the name of the structure? A, I had written here like this, because we are doing the vertical structure. So this is the structure you found. So what should you name it? Well, make it horizontal. This is the horizontal structure. Okay. This is one lone pair. This is one lone pair. See, these two are not visible. Then how does the structure looks like? Tell. These two are not visible. How does it looks like? The structure? Think of English alphabet. Is there any
V-shape.
English alphabet like this? Huh?
Shape.
Yes, yes. Tell. How does it look like? Do
30.
you write in English alphabet like this? Hello?
30.
Yes, this is called T shape. So this is called T shape. BrCl3. What is the number of valential electrons on halogen? Number of valential electron. Tell me. How many electrons you have in the valential of halogen? Fluorine, chlorine, bromine, iodine. How many?
7. 7.
Huh?
7.
How many? Your voice is not clear.
7. Sir, 7.
Very good. How many bonds it has formed? Bromine is connected to how many atoms?
3.
Number of bond pairs. It is 3. See, in this bond of bromine and chlorine, bromine has given 1 electron and chlorine has given 1 electron. Okay. So out of 7, how many electrons are present in, or bromine is present in this 3 bond pair? How many?
6.
For forming 3 bromine chlorine bond, bromine has given how many electrons?
6, sir.
Maria Thanda Khuridumu. In this bond, how many electron bromine has given?
1.
Then in 3 bonds, how many bromine will give?
3.
Hopeless. So right. So how many electrons? How many electrons are not used for bonding?
4.
4. So how many pairs?
2.
Ah. Number of lone pairs? 2. What is the model? A, B, 3, E, 2. So structure you draw. Structure, draw the structure. Okay, name of the structure is what? T shape. Draw it. Draw the structure.
Done, sir.
এই যে কিন্তু ভিতর দোষ না দুই পৃষ্ঠা ভরে রাখছেন তো তখন দেখো নি কেন This is the one. Now you have AB5E. What is the equivalent structure? Equivalent structure is with our original model. ABC.
86.
Sorry. Equivalent model. So what are the structure? Structure is octahedral. Okay. So octahedral, how did it look like? This was all original structure. See here. Here all are 90 degree. So you can replace any one by B. You can replace any one by B. So let me remove from the bottom. So in this case, what will be the structure of AB5E? Let me replace it from the bottom. A. So this is the lone pair. See here, electron pair is there, but is not visible to us. This is not visible. See, how does it look like? It looks like a pyramid. What is the base of the pyramid? Here it is square pyramid. Square pyramid.
Sir, done.
Okay. Now example. Example is BR F5, I F5, XCO F4. You do for this so you just now you have done. So write down all these things, number of valence electrons and everything. Now you know both of halogen. So number of valence electron is 7. Do. B R this outlining need not give also, huh? These are not bonds, huh? These are the outline, just to show the structure. So it is square era square bracket. This one I'm going to do it for you. See, xenon is a noble gas. The number of electrons is 8. Number of bond pairs, you need not worry. Just count the number of elements bonded. 4 plus 1, 5. Then number of lone pair. So here you have to be little careful. See, valency of fluorine is 1. So 4 fluorine. So fluorine, 4 fluorine has taken 4 electrons. Number of valency of oxygen is 2. So it has only 1. So it has taken 2 electrons of xenon. So total number of electrons how much? Total is 6 electrons. Okay. Number of bond pair is 5, but electron taken is 6. Then lone pair. Lone pair is equal to what? 8 minus 6, 2. It is 1 lone. So it is 1. What is the model? Model is AB 5E. Okay, what is the structure now? Structure, see, we'll draw it like this. Xenon is going to form double bond with oxygen. See here, double bond, 2 electrons. So this is one fluorine, this is another fluorine, this is another fluorine, this is another fluorine. So, and this is the lone pair, which is not visible to us. Or E2. What is the equivalent structure? What is the equivalent model? It's AB6. Is it not? What should be the structure now here? See here. A, B, 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 B. This was the octal structure. Now I have to remove 2 B by lone pair. See, I cannot put 2 lone pair side by side. I cannot put it here and here because then you will have maximum repulsion, 90 degrees. So I remove this one and this one I remove. 180 degree, zero repulsion. So what I do now here for AB2 is AB4 E2. The structure will be A is one lone pair, is the one lone pair. B, 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 and B. See, this is not visible, this is not visible. So it is a plane. What type of plane? Square. So it's called square planar.
হ্যাঁ সেটা প্রথম থেকেই করতে লাগে একটা একটা করে জল দেখে আসতে করতেই লাগে
To do this one, because you know very well. Xc4. Valence electron is 4. If here is general for is 8. Do.
আমার ক্ষমতা নাই মানে কি ওটা তোর পাল্টাটা রান্না করতে মনে রাখছি তোর পাল্টাতে
It's almost time for you. But anyway, a number of bond pairs 4. So 8 minus 4, each fluorine has taken 1 electron. So 4. How many electrons are left? 4. Number of bond pair is what? So lone pair 2. What is the model? AB4 E2. So how it will look like? F, 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 F. See. This. Please remember one thing. All the structures which are being proposed. Those days people did not use any X-ray machines, were not there. Only by simple logic and understanding of chemistry. And later on, all the structure has matched with the original one. This is the beauty of science. Even a non-existent molecule structure they have given, and it has matched with the original one. Maybe in 1-2 cases it might have differed. So next Wednesday, I'm going to start with valence bond theory, and after that, followed by molecular orbital theory. The next Friday,